The automated waste segregator.
This is the video demonstration of the basic construction and working of the automated waste segregator. It is a novel concept for segregation in urban households to reduce the existing pressure on waste management in municipalities. The main components used in the segregator are the inductive sensing system, the capacitive sensing system, IR sensor modules, and DC motors. The segregator employs TI's low-power MSP430 microcontroller for its operation. We now move on to the construction of the segregator. The top of the segregator has an inclined flap for the waste to drop down. An IR sensor indicates the arrival of waste. The second stage is the wooden incline, which houses the LDC 1000 and the inductive coil. This system is used for the detection of metallic waste. From there, we move on to the capacitive sensing system to distinguish between biodegradable and non-biodegradable waste. On the identification of the origin of waste, the circular panel rotates so that the appropriate bin comes to rest under the capacitive sensors. The capacitive sensing system also has a collapsible base so that waste falls down to the appropriate bin. The rotation of the circular panel and the collapsible base is controlled by DC motors and IR sensor modules.
The following section gives an overview of the TI components used in the system.
Several TI ICs have been used to implement the segregator. TI's MSP430 G2553 version 5 low-cost, ultra-low power microcontroller has been used to implement the segregator. Two types of dual SPDT analog switch ICs have been used. They are TS3A24157 and TS5A23159. Motor driver IC DRV8839 is a dual half H-bridge motor driver used to drive the DC motors. Finally, we have the LDC 1000 for inductive sensing, which has an advantage in terms of high resolution in short ranges.
Here's a diagram of the structure. Inductive sensing using LDC 1000.
In the sensor part of the code, it can be seen that 50 samples have been averaged to calibrate the LDC for its threshold value for metal detection. When a metal object is brought close to the coil, an interrupt is generated to the MSP430 indicating that a metal object has been detected.
Capacitive sensing using MSP430.
In this project, pin oscillator method is used to measure the capacitance value of the capacitive sensor. 20 samples are taken to establish a base capacitance value without the presence of any object in between the plates. When a biodegradable material is dropped in between the plates, there is a change in capacitance value due to the introduction of a high dielectric. The change in the capacitance exceeds the threshold and hence the object is detected as biodegradable. When a non-biodegradable material such as paper or plastic is dropped in between the plates, the change in capacitance value is observed is not significant. Many samples are taken to ensure that there is no change in the capacitance value over a time period. Since we know that an object is dropped and that it's not biodegradable, as there is no change in capacitance value, we could conclude that the object is not biodegradable.
Rotating panel with IR sensors.
Once the garbage type has been decided, a DC motor is used to rotate the bin under the corresponding garbage type. The IR sensor is used to stop the bin from overshooting its location. As it can be seen, the IR sensor produces a low to high transition upon the bin arrival to its position.
Flap mechanism.
A DC motor is used to control the flap. Enough time is provided for the garbage to fall down and then the flap is brought back up to its position.
PCB etching.
This is the making of our PCB. We are etching it in FeCl3, the top layer, the bottom layer, the PCB with ICs soldered on it.
Hope you enjoyed the show. Thank you.